It is my exquisite pleasure to introduce Professor John Echeverria, who will be the moderator for our second panel on ocean waste. And I will do an abridged biography this time. So, Professor John Echeverria is a professor of law at Vermont Law School, where he teaches property, public law, and a wide range of environmental and natural resources law courses. He received a JD from the Yale Law School. He received a master's degree from the Yale Law School of Forestry and Environmental Studies, as well as a bachelor's degree from Yale College, summa cum laude. And I can tell you he is also a man whose facial expression does not change whether you have the right answer or the wrong answer in property class. So without further ado.
Is that a good thing or a bad thing? Bad. It's good to have feedback like that. Okay, now we are turning to the oceans and waste. And we have three distinguished panelists whose biographies are laid out in full detail in the set of biographies at the registration desk. And in the interest of time, and so we have plenty of time for debate and questions, I'm going to give very abbreviated introductions to all of our panelists, who will then proceed in the order that they appear in the program. Dr. Law is the speaker today who wins the prize for the best photo. We have a picture of her in the biography standing in rigging of a boat, which is far superior to any other offering we've had. Dr. Law is a research professor at Sea Education Association in Woods Hole, Massachusetts. She's a physical oceanographer, and like our own Professor Baker, she spends a lot of time on the water. Our second speaker is Nicholas Mallos, who is the director of the Ocean Conservancy's Trash-Free Seas program. He too seems to spend most of his time on boats traveling around the world. And then our final speaker is Megan Herzog, who is the Emmett Frankel Fellow in Environmental Law and Policy at UCLA School of Law, where she teaches ocean and coastal law and policy and conducts a variety of research projects related to the oceans. So without further ado, I'm going to turn it over to Dr. Law.
All right, well, thank you so much. It's great to be here. This is not my typical audience. I am a scientist studying ocean plastic. And I want to thank all of you, first of all, for dedicating your day to waste, because I think it's a really important topic and one we don't talk about enough. And what we're going to talk about now for the next hour plus is ocean trash, or what those of us in the field like to refer to as more formally marine debris. So marine debris science, or the field, is very interdisciplinary. It includes environmental science, aspects of waste management, polymer science, marine ecology, and my background, which is oceanography, and then also very important elements of social science, which will become obvious. So as such, it's a really interesting realm in which to work. The topic also receives a lot of public attention because there are very impassioned ocean conservationists, as well as anti-plastic activists who are engaged in this topic. So you see a lot of information in the public and in the media on ocean trash. Unfortunately, much of the information that you find is not accurate. And it's widely sort of propagated. And in my experience, I found that even audiences of marine scientists sort of fall prey to these misconceptions. So what I'm going to do today is give you a very, very fast look at what I think is sort of the state of marine debris science in the ocean. And in order to do that, we're going to begin by first debunking some of those myths. So I'm sure some of you in the room have probably heard of the Great Pacific Garbage Patch. Yep, at least one hand. Okay, thanks. Or also the Great Atlantic Garbage Patch. And what you may find if you Google this is images that look like this, with sort of large amounts of accumulated trash that appear to be floating out in the open ocean. And while some of these images may be real photographs, I would warn you to be very careful and look at the captions to see where they were taken or how they were attributed. Because some of them, like the one on the bottom there, I think are probably subject to Photoshop. Now, these large masses of plastic, these floating islands that you can walk on, floating landfills, twice the size of Texas, these are the kinds of terms that you'll hear, and even reputable people tend to use these descriptions. And Oprah said it was the most shocking thing she's ever seen, which I think is shocking. So beware. These are not really accurate descriptions of the problem. So I'm going to take you through a little bit of a tour of the subtropical ocean where we find these quote-unquote garbage patches. And I'm happy to see one of my former students who has sailed through this part of the ocean in the audience, who is now a student here, so she can confirm that these are not photoshopped. So these are just images that were taken, I think, in the Pacific, but it could be the Atlantic as well, in the middle of the subtropical gyre, the part of the ocean where these plastics accumulate. And what you see is typically you have very flat, calm seas, you see sky, you see ocean. Occasionally you see something shocking float by, perhaps something you recognize like a boot or a 5-gallon bucket, and these things clearly do not belong in the middle of the ocean. More often you'll see something that floats by that may not be recognizable. Perhaps this is some kind of fishing, a fishing buoy or containers. Hard to say, it could be fragments of items. Very rarely will you find things that you think you can actually attribute the origin to. So these are images that were taken on a research cruise that we carried out in 2012 in the Pacific. And these are items we suspect to have originated from the Japanese tsunami. So you can see in the upper left we have a floating refrigerator. The folks on board were able to open that drawer, and that's what you see below are images of things that were found in the refrigerator. So food packaging with Asian characters, likely from Japan. Also you see a lot of larger objects over there, soccer balls, bottles, fishing buoys, things that are likely to have originated from Japan. This is quite rare that we can actually say where the item probably came from. Rather, most of the time what you find are little tiny bits of plastic, referred to as microplastics, that are quite difficult to spot even from the deck of a ship, let alone from an aircraft or from a satellite. So microplastics are the most abundant form of plastic in the ocean, and even though they're this small, you might think, oh, not a big problem, who cares about that? These actually can be far more insidious of a problem. So even though it may not be what you sort of had in your mind when you walked into this room today as a garbage patch, this is a very real contaminant that warrants concern. So let's take a step back and just define what is marine debris so we're all on the same page. Marine debris is a man-made material that persists in the marine environment, and the marine environment includes beaches and shorelines. This is a photo of Camilla Beach in Hawaii, which is sort of a famous beach that accumulates a lot of junk that comes from the ocean that's not generated locally. Marine debris also can accumulate in the water column, so these are photos again from the middle of the ocean in the Pacific. And it can also accumulate on the seafloor. So I'm sure it's kind of hard to tell from the back, but the images here on the top are of a couple of water bottles that were found at 1,000 meters depth. That's about 3,000 feet deep in canyons in the Mediterranean. And below that you see some kind of plastic packaging that was found more than 2,000 meters deep under the ice in the Arctic. So this is human trash found far away. Sometimes you also get in the, you never know what you're going to get category. We found a Ken doll off of Rhode Island that had clearly been sitting on the seafloor for quite a long time. So marine debris can actually be composed of any kind of man-made material, paper, plastic, it can be wood, metal, glass. Most of what's found floating in the open ocean and what's found on beaches is composed of plastic. It's sort of loosely estimated that 60 to 80% of this marine debris is made of plastic, but that hasn't been very well quantified. Plastic is constructed to be very durable and to be long-lasting, and so it's actually very persistent in the environment. We don't know a whole lot about its behavior in seawater, but we do know that plastic, when it's exposed to ultraviolet radiation, does weaken. If you think about that beach toy that you may have found sitting out for a couple weeks, it gets very brittle and it can fragment quite easily into very small pieces. We don't have any concept of how small those pieces get, or if those ultimately are broken down by microbes in the environment. It depends whether you're talking to the polymer chemist who says that that's impossible, or if you're talking to the microbial ecologist who says microbes can do anything. We're still trying to answer that question. So what are the sources of marine debris, or specifically plastic, into the ocean? We know that plastic has sources on land and also from sea-based activities. I will say the source of all plastic is human, of course, and does all originate on land where it's been manufactured. But in terms of its use, this is what we're talking about. So on land, there's litter and waste that might be either intentionally or unintentionally dumped into the ocean. But in the terms of litter, we have sources including beaches, where things left on the beach can be washed out to sea, rivers and waterways, and this is a very provocative image of the Los Angeles River after a very large rainstorm, which I guess is quite rare now. And you'll see that there's all of this debris that washed from waterways into the river and is being captured by these booms. So this is all floating debris that's being prevented from entering the ocean, which is a good thing. Other small waterways, including drainage outflows and runoff, can carry any kind of trash into the ocean. And then, of course, winds. So if you think about some of the nor'easters kind of weather that we've been having here, anything that's light can be blown offshore. A category that's not often talked about in this sense is catastrophic events, but of course, if you think about the Japanese tsunami or Indonesian tsunami, or the floods that were experienced even in Vermont with the hurricanes a few years ago, these kinds of catastrophic events will carry any and all material into the ocean in sort of one fell swoop. In terms of the sources that originate from sea, we have ships and at-sea platforms that may, again, intentionally or unintentionally dump material into the ocean. It has been, the dumping of plastic into the ocean has been banned internationally since 1988, but of course the ocean is a pretty big place to police, so it's quite likely that dumping is still happening. There are things like lost cargo. You hear about floating rubber duckies and Nikes and other things that have come off of cargo ships. Fishing and aquaculture activities. Gear is either accidentally lost or perhaps it's a way of also disposing of material. And then, of course, recreational activities, and yes, oceanographic activities. A lot of the instrumentation that we use and deploy into the ocean for single use is made of plastic. A sort of more recent category of material that's been talked about a lot lately is plastic that's actually microscopic in nature when it enters the ocean. So what we were talking about previously are sort of larger objects that will ultimately break down into these small pieces. But then there are things like cosmetic microbeads that are manufactured in that small size. And when those materials are used properly, you're using your facial scrub, you wash your face, and that goes down the drain. The particles are small enough that they pass through any kind of wastewater filtering, and then they can directly enter the environment. And so you get a sense of the scale from that penny photo there of just how small these beads are. And these things are in facial scrubs and toothpaste, other cosmetic products. And then there are clothing fibers. We're starting to enter into fleece season here. And if you just do your laundry like a regular person does, it's been shown that these small fibers can come off of your plastic clothing and again directly enter wastewater treatment where it's being properly disposed of, which can flow directly into the ocean. So it's important to note that in terms of all of these sources, we don't have a really good sense of what the biggest sources are. In other words, if you wanted to direct your efforts into stopping the flow of plastic into the ocean, where should you target? This is something that we're actively working on. I'm involved in a working group trying to estimate the size of some of these sources. But at this point, it's hard to say whether tsunamis are carrying the bulk of the material in versus litter on land that has been lost. So where in the ocean do we find this plastic? At this point, I'm going to restrict the talk to just the floating microplastics because really that's where most of the information lies. This is also where the tall ship rigging comes in. So my organization, Sea Education Association, is primarily an educational organization. We take students to sea to study the ocean from a variety of perspectives, including doing hands-on oceanographic research on these beautiful tall sailing ships. So as part of our sea semester program, students again are deploying oceanographic equipment to collect data for their individual research projects. And one of the workhorse instruments or pieces of equipment we use is this plankton net here called the Newston net. So we tow the Newston net for about a nautical mile, about a half an hour. We filter the equivalent of about 2,000 bathtubs of water, and then we count the plastic bits that come out of that net. And that's where the students become very important, because that is extremely tedious work. So we've been doing this in the western North Atlantic Ocean. So here's the US, so here's the western North Atlantic and the Caribbean Sea. We've been towing this net for over 30 years, and one of our scientists in the 1980s had the foresight to actually write down the numbers of plastics that were coming up in the net and actually to save those samples. So what I'm showing here is a map of the concentration of plastic debris, those microplastics, in the units of pieces per square kilometer. So each dot on this map represents a single net tow that was done between 1986 and 2010, so there are more than 6,600 points on this map. And each symbol is colored by the concentration of plastic that was measured. So the blues are low values, the reds are high values, and the highest values are indicated by those black stars that you can see in here. So there are a few things to notice. First of all, the highest values, all those black stars, are quite far offshore. This may be kind of surprising because I think we all think that most of the plastic originates from land. But in fact, because of ocean currents, the bulk of this plastic is accumulating offshore in an area that spans the subtropics. So using ocean physics, which is my background, we can pretty easily explain this pattern. One thing that I want to mention is that, oops, we get really high values. This is what a typical collection from a net includes. So this is from a single net tow, the amount of plastic that was collected, and I can't really see the number. There are 240 pieces of plastic in that petri dish, and that scales to 130,000 pieces per square kilometer. So that is the equivalent of one of these red dots. So even though it's not a huge mass of plastic, you could easily hold this in the palm of your hand, it is still a high value in terms of concentration. Okay, I'm going to skip, well, briefly, hard to skip, but I'm running out of time here. These concentrations exist in 5 of the different ocean gyres. This is a numerical model, but we have a good indication that certainly we know plastic accumulates in the North Atlantic and North Pacific. It's likely also accumulating in these places in the Southern Hemisphere. I need to briefly talk about the ecological impacts of the debris because ultimately that's what we care about. From large debris, we know that entanglement is a serious hazard. I'm not going to go into detail because I think it's pretty obvious the badness that happens when things get entangled in large debris. One ecological impact for anything from a large piece of debris down to the smallest microplastics, which are indicated in this picture here, is that we're putting a new substrate out in the ocean for organisms to build their homes on. If you find any kind of piece of debris larger than an inch or two, you'll find encrusting organisms like crabs and barnacles, all the way down to the smallest pieces of debris which have microbial communities that are quite distinct from what's growing in the ocean water surrounding it. So we're not entirely sure what the long-term impact of this is, but this is a mechanism for transferring species around the ocean and for them to potentially become invasive species. Ingestion is also a huge problem. Now we're talking about typically smaller debris. This is an albatross chick, which has, probably hard to see in the back, but there's a cigarette lighter and bottle caps, other recognizable items in this albatross chick that is no longer living. We can find plastic debris in fish. This is a fish that we caught that had something like 40 pieces of microplastic in its stomach. These are fish bites out of bottles found on a beach. And all the way down to invertebrates can ingest these really small pieces of plastic. So this is where the fact that it's a microplastic becomes even more dangerous because it's accessible to a wide range of organisms from your largest filter feeders down to your invertebrates. And then lastly, organic pollutants, and this is where it kind of ties into the ingestion risk. We know that plastic acts as a very good sponge for contaminants that are already present in the marine environment. Also, some of the additives that are put in the plastic during manufacture can be toxic. So the question is, what happens now if all these range of organisms are eating these microplastics that have these poisonous, toxic contaminants attached to them or in them? And the risk, of course, the concern is that we're actually causing our food supply to become contaminated. But there are a lot of open questions between the fish eats a toxic piece of plastic and your tuna on your plate is contaminated as a result. So this is a focus where a lot of research is happening. I'm happy to talk about that a little bit more in the discussion. But in the interest of time, I do want us to move on to the solutions slide. Suffice it to say, I still eat fish, but there is good reason for concern about this problem. So what can we do about this problem? I've broken this down into just 2 pieces. First, there's the what can I do? And you're all familiar with this. You're at an environmental law school. You probably all have a water bottle somewhere and a reusable coffee cup. But the first thing is if we reduce waste, then there's just less stuff available to enter the ocean. And the way to reduce waste, first and foremost, is to reduce consumption. So reduce the amount of single-use plastics, for example, that we use in our daily lives. Say no to the straw, carry your reusable items, etc. Second, we're still generating waste. We need to figure out a way to prevent the waste from entering the ocean. So this comes down to things like picking up trash anywhere you see it, because we know, according to Nemo, that all drains lead to the ocean. So pick up a piece of, a plastic bag floating out here to prevent it from contaminating the environment. If you're close to a beach, you can participate in beach cleanups. Also, please don't ever release a helium balloon into the environment. Sure. Things like that. So trying to cut off the flow of plastic from the source. Spread the word, of course, because education and outreach are so important. And then there are policy initiatives, which I'm not going to speak about because others are definitely more qualified on that front. But things like plastic bag bans, banning polystyrene. But I think what has to be done to really solve this problem on a global level is to improve waste management structure. So some of my colleagues in the waste management field have taken photos like this of a drainage area in Vietnam where people just dump their trash, and this feeds a river which eventually goes into the South China Sea. This was actually a Google image, so I can't really say anything about its veracity, but there's a sign here saying no dumping, and this is clearly an open dump. And in much of the developing world, this is a very real problem, and so we have to figure out a way to actually capture that waste before it does more damage in the environment. And so I think with that, I'll pause and let us move on.
Hello, and I just want to echo Kara's thanks to everyone for having this session today and for inviting me to come here and speak. And one nice thing about being on a panel with two people you know, and actually I'm fortunate to know Kara very well, that you can tailor your talks quite nicely. So I'm essentially going to pick up where Kara left off and talk about kind of the solutions focused. And she's done a great job of laying out the science and what we know about this issue and the impacts. So I'd like to talk a little bit about the solution set moving forward. So Ocean Conservancy for the past 3 decades has been overseeing what's called the International Coastal Cleanup. And each September around the world on the 3rd Saturday of the month, volunteers from over 150 countries come out and collect trash from their beaches, their waterways, underwater habitats. And what's unique about the International Coastal Cleanup is that you're not just picking up this trash to get it off the beach, but volunteers document every item of trash they collect on our standardized data form. And so over the course of these 3 decades, we have amassed a global data set that's allowed us to document the most persistent items of trash that are appearing on our beaches over time and in geographical locations. And this just kind of spotlights where the largest participating countries occurred during last year's cleanup. And what we have seen over these 30 years is probably no surprise, is that there's a lot of trash out there. And we've seen more than 10 million volunteers over those 30 years. We get about 600,000 volunteers coming out each year. Last year it was around 650,000 people, and they've collected over 175 million pounds of trash. And again, that's on a single day on a very small fraction of our global coastline. And what's particularly staggering about this is over these years is not so much the volume, not so much the poundage, but if we look at the sheer number of items that have been collected, it exceeds 200 million. And so when we think about this, it's a small snapshot that really highlights the issue that Kara was talking about. And when we think about the items that we are finding, what do they look like? Well, there's not a whole lot of variability. Each year, the same items appear in the same quantities. And the data here just show a 10-year period from 2002 to 2012 of the top 10 most persistent items found on the beaches. And what you'll notice at the very top, it doesn't even make the chart, is that cigarette butts are, every year for the past 29 years, have been the most common item. We found 52 million cigarette butts alone on these beaches. And so we removed that from the chart so it doesn't inflate the graphic. But aside from cigarette butts, what you'll notice is that the other products you see here are largely everyday single-use convenience packaging. And most of it is focused around food and beverage. And again, it's important to note that while Kara talks about the survey trawls that are being done on the ocean, the International Coastal Cleanup is very much quasi-citizen science. It is volunteers, families that go out once a year, pick up this trash and document this. Often, the distances aren't perfectly quantified, so what we're talking about here is not rigorous science, but it is citizen science, and it does provide us, a snapshot and an understanding of what the environment looks like. And what you'll see is that when we corrected for the volunteer effort each year, and look at the number of items collected per person, while the number of items is not necessarily going up, we're seeing a consistent trend in the trash we're finding. That means every year we go out, we pick up trash, we go home, and the next year we go out, the same amount of trash, more or less, is there again. So what that indicates is that we are failing upstream to actually address this issue. And again, to underscore a point Kara made previously, is what we're finding is largely plastic packaging. And if we look at the total items found, of those 200 million items I talked about, more than 50% of those, so about 100 million of those items, is comprised of these items right here that are predominantly plastic food and beverage packaging. And so when we think about the global landscape and all of these items that end up on our beaches, yes, they are all problematic, but if we truly think about what are the most common items, they are the plastic, single-use food and beverage packaging that we use in our daily lives. And what's even more concerning is that these items in and of themselves do pose a threat in the marine environment, do pose a threat on the beach. But it is truly once they begin to fragment into these smaller pieces, as Kara described, that they become truly problematic. And Kara showed a picture of Camila Point in Hawaii, and this is actually a photograph I took from Camila Point. And Camila sits at the southern tip of the Big Island, Hawaii. It's nicknamed Junk Beach because of the way it's situated within the currents, and it basically acts like a hand and grabs all of the trash that circulates around those islands. And when I was there 2 years ago with some researchers, we took a 1 meter by 1 meter quadrat sample and looked at all of the microplastics that we found just in that surface level, 2 centimeters deep. And we counted more than 84,000 pieces of these small little fragments just in that 1 square meter. And so when we start thinking about some of these global challenges that we face, yes, it is the problems, yes, it is the water bottles, yes, it's the plastic bags, but how do we think about solutions that don't just address an item by item, but actually look at this issue holistically? And so when we talk about solutions, plastic grocery bag bans, polystyrene, like the Dunkin' Donut cups that are being discussed right now, and phasing those out for another material that is recyclable in the everyday streams, and the cosmetic microbead bans, these are perfect examples of product-specific approaches that are appropriate for solutions. These items are not necessary in our daily lives. There are suitable alternatives, and I think Megan is going to go into much greater detail about some of the efforts that are being done in California and elsewhere on these items. So there are some product-specific bans and legislations that are appropriate to deal with these problems. But even if we were to look at, and again, taking the international coastal cleanup data that I showed earlier, even if we were able to ban our way out of all of those items, the plastic bottles, the plastic bags, glass bottles, etc., we'd still be left with 80% of those materials still on our beaches, still entering the marine environment. So how do we think about a holistic approach, again, that addresses plastics as a whole on a global scale? And one of the reasons we have to do that is, as Kara touched on, because global waste is skyrocketing. We know that waste is a problem. This panel and this session today exists because waste is so problematic. But if we look at the projections over the next 13 years, and this comes from the World Bank and the economists, what we see is that the generation of municipal solid waste is going to skyrocket. And particularly where we see this most is in Southeast Asia and the Pacific Islands. And so when we think about how we need to address this, we need to think about strategies that are going to not just focus in the United States, not just focus in the EU, where we are already doing fairly well compared to other parts of the world, and think about strategies that address this issue on a global scale. And so the reason that rapid development and the rapid industrialization is occurring, and we're seeing this waste generation in Southeast Asia and other parts of the Pacific Rim, is because we're seeing booming populations, we're seeing large percentages of that population entering into the middle income class, and what we know is with that increase in affluence, we also see an increase in consumption. And much of the consumption that is taking place there is in the form of single-use disposable plastics. And one of the consultants that Jen actually, or I'm sorry, Kara referenced, that we've worked with over the years, who's an expert on solid waste, has talked about the fact that the actual composition of waste has changed drastically from a place where it used to be dirt and organics to a place where plastics now comprise 10 to 20% of our total waste stream by weight. And so with all of these factors combined, we're seeing these increased hotspots and where we're going to have huge waste problems if we don't intervene. And what is particularly challenging with these increasing populations and this increasing consumption is that the basic waste management to handle this influx of materials is either drastically lacking or in some places non-existent. So how do we actually think about addressing that? And all of this is talk, but the pictures really speak for themselves. And so this is a photograph that I took several weeks ago when I was down in Peru on one of their beaches, and this is actually one of their most popular tourist beaches in the summertime in Lima. And outside of the tourist season, when they don't pay people to come and clean, this is what happens. And a lot of this debris is actually washing on shore from the ocean that is being dumped and finding its way into the water from south of this specific beach. And on another beach, this is considered Lima's dirtiest beach, actually. It's known as Carpallo. In 2 hours, 300 people and I participated in a cleanup here, and we removed 26,000 pounds of trash. And I'm sorry to say, after those 2 hours, you couldn't even tell that we had actually removed those pounds because there was such an exorbitant amount of waste on that beach. And so these are the challenges we face, and a lot of this is due to just lack of infrastructure, lack of accessibility to infrastructure, and incredibly important is also increasing education and awareness about this issue. And then lastly, this is a picture that I think many people may be familiar with, but this is from the Citarum River in Indonesia. And this young boy is actually picking out the straws from that river because you can actually get a little bit of value from those straws by recycling there. And so the Citarum River in Indonesia is one example where if you look at the amount of waste that has been documented to be dumped into that river annually and look at the percentage of plastics that is in our waste stream, an estimate is that potentially 35,000 tons of plastics enter the Citarum River annually just in that one location. And so just a few pictures really underscore the problem. So how do we think about actually addressing this issue? Well, if you talk to waste management experts, it's not rocket science in a lot of these places. And what you need is the simple foundations that allow communities to actually process and collect their debris. And so in a lot of places, it's moving from a place of manual collection of throwing trash out on the corners to creating centralized collection points in the communities, and then providing transport and other mechanisms so that you put in place a basic foundation so that recycling can occur, you can leverage the informal scavenging sector that is present in a lot of these communities, and once you have these infrastructure and these basic collection capacities, you can then move to a place where you start talking about circular economies and zero waste types of policies. And so without the basic collection, though, as you can see here at the very core of the circular economy discussion, is the basic collection. And so while we may talk about this as waste management, we may talk about this as trash cans, recycling, essentially the circular economy discussions that are taking place right now in Germany and the EU are appropriate for those communities. But providing the basic waste management infrastructure in many of these developing geographies is, in essence, the first step towards moving towards a circular economy. And so what Ocean Conservancy has been doing is thinking about how do we actually work on the global scale with many of the players out there to try and catalyze the development of this waste management infrastructure. And what is readily apparent is that government alone cannot solve this problem. And when we think about who are some of the major players in these geographies, who are the players that will benefit most from these emerging economies, we have to look at the global consumer product companies and the global plastics manufacturers. And so thinking about the fact that they have global reach, they understand the institutional structure and dynamics that take place, and they have the world-class financing and logistical understanding, we need to start thinking about how we can bring those conversations together and put in place a mechanism that may, in fact, be able to provide capital to these communities to start building the basic building blocks for their infrastructure. And so, several weeks ago in Chicago, the Ocean Conservancy has what's called the Trash Free Seas Alliance. And it's a group of industry members as well as other NGOs and a science advisory board, which Dr. Lavendar actually sits on. You can see her there in the middle. We came together to talk about this global idea and think about how could those players in the room come together and think about solutions. And it was a very successful meeting, and emerging that meeting, ITW, the Coca-Cola company, Dow Chemical Company, and Veritiv, which is a global packaging company, all agreed and expressed their commitment to explore a global financing mechanism with Ocean Conservancy and the Trash Free Seas Alliance over the next 12 months to think about how we, as an ocean conservation organization, as the global corporations in that room, can come together and help catalyze this basic infrastructure that is the foundation for all future policies and plastic reduction measures to come. So thank you very much, and I'll allow Megan to dive into the specifics on actual policies. So thank you.
So thank you so much, to be jealous, to echo my fellow panelists. Thanks for having us here for this inspiring conference. I'm delighted to participate. So for the past several years, I have been working through UCLA's Emmett Institute with ocean conservation groups and local government in California to defend and promote policies that address this problem of marine trash. So today I'm going to very briefly characterize the problem, building on what you've already heard. I'm going to talk about the menu of policy initiatives that are available at the state, local, and maybe federal government here to address the problem. And then I'm going to share some examples of what local governments in California and the state government has been up to address this problem. So first, as Kara mentioned, we have all of these different sources of trash that ultimately lead to the ocean. And in order to effectively target our policies, we need to know where we need to put our long policy interventions. So as Kara mentioned, we have ocean-based sources of plastics, things like fishing vessels, things like cargo ships, and we have land-based sources of plastics, like spills at manufacturing sites and, in general, improper waste management that ends up in the ocean. And there's a lot that we don't know about the composition of the trash that ends up in the marine environment, but we have rough estimates that a lot of it is from land-based sources, and that most of it is plastic at many of the places where we're taking samples. And we have really rough estimates about how much trash in general is getting into the oceans, but it's been estimated that maybe something on the order of 20 million tons of plastic trash is entering the ocean every year. So this is rough, but in general, it represents that the scale of the problem is critical. And as Nick mentioned, we know from coastal cleanup data that a lot of the most commonly found items littered in the coastal environment include single-use products associated with our to-go lifestyle. So things like plastic bottle caps, plastic beverage containers, plastic carry-out bags, and food packaging and wrappers. And we know that when we're looking at plastic products, that almost half of the products that are made out of plastic are intended to be used only once. They're used for an average of about 12 minutes, and then we discard them. And despite the fact that we are generally producing these products to be discarded, they're very durable products. They don't degrade easily. They can persist in the marine environment for a very, very long time. And they're also buoyant and lightweight and durable, and have all these qualities that allow them to be carried by the wind and the waves, ultimately into the ocean. So here's a graph that shows U.S. plastics generation and recovery, meaning recycling, since 1960. And as you can see, plastics generation has been increasing rapidly at a rate of about 5% growth per year, while recovery has remained basically stagnant over that time. So we're increasingly producing products that we're not capturing through recycling, and they end up as plastic trash. They end up in the landfills, and increasingly here. So this is my neighborhood. This is Santa Monica Beach and Venice Beach. Last fall, after what we call the first flush, which is the first big rainstorm of the season, the hydrology in Southern California is characterized by long periods of dry weather and then flashy flood storms. So the trash is a chance to build up on the streets and in the stormwater system, and then the first rain flushes it all out to the coastal environment. The stormwater in Los Angeles is captured by a municipal separate storm sewer system, an MS4. It's untreated, it flows directly into the ocean, and we end up with the beaches that look like this, and eventually it can end up in the Santa Monica Bay and have all of those terrible environmental impacts that Dr. Lavendar mentioned earlier. And it also has economic impacts for local governments. So tourism is the #1 industry in California. Does anyone want to go hang out at this beach? I don't think so. And it also costs billions of dollars for local governments around the US to deal with litter like this every year. So, given what we know about the problem, we can think about policy interventions as falling into these 5 basic categories. So first, redesigning products and reducing the products that we're using. So use less stuff, use greener stuff. And then the stuff that we do use, increasing the rates at which they're recovered through recycling. And for the stuff that we can't or don't recycle, we should prevent it from being littered, and we should prevent it from being becoming fugitive waste. And for all the things that inevitably aren't captured in the municipal waste stream, we should mitigate their impacts, either by preventing them from entering the ocean through stormwater controls or cleaning them up. And we should be continually monitoring and assessing the effectiveness of our policy interventions so that we can go back and adaptively manage the way that we're addressing this problem. And so I'm going to share a few examples of things that California has been doing that fall into each of these categories that hopefully we can draw lessons from for other jurisdictions and for future action. So first, thinking about product redesign and reduction, I am really proud to be able to stand here and say that California, as of last month, is the first state in the country to ban plastic carry-out bags at grocery stores and major retailers. This is a long-fought battle. It's been tried in 17 states. It's been tried for years in California. It was the most contentious bill, probably, of this legislative session. So this was a hard fight. But we're finally now victorious. As of 2015, large retailers will now be prohibited from providing plastic carryout bags. And this restriction is coupled with a 10-cent charge on recycled paper or compostable or multi-use bags. And I brought my Chico bag here so you can see. Consumers have to bring stuff like this. Chico Bag is a California company, so we're creating local jobs. And a major part of getting this bill passed was working with the California Grocers Association and getting them on board. This bill was coupled with $2 million in grants to plastic bag manufacturing plants to help them to convert into reusable bag manufacturing plants. And of course there's carve-out exemptions for things like meat at the grocery store and fruit and vegetables. This is really typical in a lot of plastic bag type bans. And some exemptions for people who are purchasing, making their purchases with food stamps or EBT cards. So prior to this statewide ban, a third of Californians were already covered with plastic bag restrictions in their local jurisdictions. This is really a grassroots movement that started at the local level. And it was important to passing the statewide ban that we had these examples of policies in place at the local level that have been really effective at addressing the problem. But I don't want to say that the picture is totally rosy because the ink on the governor's signature was barely dried before the plastics industry announced that they were collecting signatures for a voter referendum to repeal this law in 2016. In general, plastics industry and retailers have really fought hard against local bag bans. California has been a forum for a lot of that litigation. They bring a lot of their weight and their money and their lawyers against local governments that have limited resources to try and take these bans down. So I think we can expect at the state level that there will be challenges ahead, but still a really exciting step. A not as rosy picture is the plastic microbead legislation. So Kara mentioned the problem of microbeads. Legislation was proposed in California to ban the sale of products carrying these microbeads. It died quietly in the Senate, much to our dismay, but it was passed in New York State, so New York State is the leader here. And hopefully this will come back again in the future, as the bag ban did. And bans on expanded polystyrene foam, so the styrofoam, takeout containers, stuff like that. They are gaining momentum at the local level. Approximately 65 cities and counties in California currently ban styrofoam as takeout containers, but it doesn't have as much momentum yet as plastic bags, but I think it's an emergent policy arena. And thinking about preventing litter and loss. So we talked about beach cleanups a lot already. Those are really important public education tools. I like to think of marine debris as a gateway environmental issue because it's something that people can immediately associate with. You go to the beach, you see like a juice box that you used yesterday sitting on the beach, and you pick it up and you can connect that to your personal life. So there are beach cleanups hosted by NGOs and by the state government up and down the coast of California. Every weekend you can go out and volunteer. We also have state legislation to control what's called nurdles. Nurdles are pre-production plastic pellets. They're about 1 to 5 millimeters in diameter. They're these little resin balls that ultimately get turned into all of the great plastic products that we use. And inevitably spills happen. You can see here at the top is spill while loading nurdles onto a railroad car in California. The bottom is, it looks like snow, but it is actually plastic on a beach in Hong Kong after a big typhoon knocked over some cargo containers that were filled with these things. So you can find nurdles everywhere. I found them hiking in the Mojave Desert in the middle of nowhere. They are everywhere. But the good news is that there's really simple things that manufacturers, transporters, and users can do to prevent the loss of them into the environment. Simple things like sealing containers properly, having containment systems in place, having vacuums available for your employees, really simple stuff. So this is now required of all plastics facilities in California as of 2008. The state agency that regulates water in California inspects these facilities and initiates enforcement proceedings against facilities that violate the law. Increasing recycling rates, also really important. You have a bottle bill here in Vermont. We have one in California too. But there are actually only 10 states across the country that have a bottle deposit and refund system. The way these work, as most of you are probably familiar with here in the Northeast, is you typically pay a charge when you purchase a beverage container, and then when you bring your beverage container back to a certified distributor or collection site, they will refund you the money that you put down on your deposit, and this provides an incentive for consumers to properly recycle beverage containers. And these laws have been shown to cut beverage container litter in half and to increase recycling rates from something on the order of 10% to something on the order of 75 or 85%. So in California, we recycle beverage containers at a rate of 82%. These are really powerful, super effective laws. They've been around for a long time, but they don't have a lot of traction. And something we've had less success with is plastic bag recycling programs. So we've had some statewide pilot programs that would require grocers and major retailers to recollect the plastic carryout bags that they issue from consumers. These are voluntary programs where consumers aren't mandated, but they can bring their bags back if they wish. These have done basically nothing to change the rates at which plastic bags are recycled. They're still recycled at a rate of about 1 to 5%. Thank you. And in addition to that, plastic bags present a lot of challenges for recycling companies because they clog and jam up the recycling sorting mechanisms, and there's also basically no market for recycled plastic bags. No one wants to buy them. They can barely be turned into anything. So in general, we've seen that financial incentives and bans on giving consumers the bags in the first place have been the most effective policy response. And so inevitably there's going to be trash that ends up in the environment, and we're going to need to prevent that to the extent that we can from getting into the oceans. So, Los Angeles area, local governments have led the way in using tools under the Federal Clean Water Act to prevent and control trash that is being carried by stormwater into the ocean. So under the Federal Clean Water Act, water bodies need to meet all of the uses that we, the public, use to, beneficial uses that we want out of our water. We want it to be a place where we can recreate, we want it to be clean, we want it to be a good habitat for fish. And if there's a pollutant that's impairing the ability of a water body to meet these uses, then regulators have to set what are called total maximum daily loads, or TMDLs. I don't know a lot of acronyms, we love them. And basically these TMDLs set a numeric limit on the amount of pollution that can enter the water body. And then anyone who discharges that pollutant is subject to these limits. In the late 90s, regulators determined that LA area water bodies were impaired for trash, the pollutant of trash, like the picture I showed you earlier and the picture I showed earlier. And they said, well, the limit for trash is going to have to be 0 because there's absolutely no capacity for the ocean and marine environments to assimilate trash. We're going to have 0 trash by 2016. So it's a really innovative. It was hard for local governments to accept. There were many years of litigation, as you might imagine. There was a lot of negotiation, and ultimately we arrived at this compromise that local governments could implement a set of controls and best management practices, including things like installing these catch basin screens, which would prevent large trash from getting into the stormwater system. Also things like increasing street sweeping, increasing enforcement of litter laws, and having these trash booms put out, these nets that capture the trash. So while we're not at 0 trash, obviously, and I don't think that we will ever be at actually 0 trash, these measures have gone a long way at preventing litter from entering the marine environment. They prevent an estimated 1.2 million pounds of trash every year from getting into Santa Monica Bay. And they've been so effective that the state is now pursuing a policy to apply this to all cities and industries and construction sites across the state of California. It'll be about 10 years before this is fully implemented, and that may seem like a really long time, but these are intensive policies that require money, and they require people like this guy to go to every single catch basin, hundreds of thousands of them in every city, and install these screens, but it's promising. And so in the interest of time, I'm just going to skip through, but I'll just say in general that these same 5 categories of policy interventions can be applied in the ocean environment as well to respond to ocean-based sources of plastic litter. And I think that in general, it's really inspiring for me to see how this is a really grassroots movement, how local governments are leading the way, how single communities can do a lot to prevent trash from entering the ocean. There's obviously still more that we can do, but I think that these examples are promising. So thank you.
Well, thank you all. That was a fabulous panel, and I'd love to be able to take credit for how well organized it was, but I can't, so I won't. I want to just start off by offering each of the panelists an opportunity to comment on what they heard or something they might have disagreed with. I was struck by there was sort of a mix of desolation and more bad news and bad news getting worse. But then we closed with something that seemed more optimistic, so I guess I'm a little confused about what the trend line is and whether this problem is actually manageable in our lifetimes.
I'll speak to the impression, Stephen, you made, but actually at the meeting we were at a couple weeks ago, one of the gentlemen that was attending someone asked a very similar question, and they said, I'm hopeful because if we look 10 years ago, maybe even 5 years ago, the general public would come up to us when we talk about trash or plastics in the ocean, and they go, oh, why is it a problem? How's it get there, et cetera, et cetera. And now the conversation is not, why is plastic in the ocean bad? The question is, how do we stop plastics from getting in the ocean? How do we create solutions? So I think public awareness has evolved. We're at a place where people understand it's a problem. They might not understand the nuances, and that's okay most of the time. So I think it's continuing to move forward, making sure we're perpetuating accurate science, accurate information, at the same time continuing to give people small bite-sized doses of how they can individually help while the rest of us work on larger systemic issues.
It sounds like, with the possible exception of Santa Monica Beach, the total loading the ocean with plastic is still going up. Is that a general whatever the improvement that has been made in terms of public awareness and education, that is not translated into reduced loading of the ocean.
So I think this comes down to my solutions slide where I had sort of outlined local versus global. So to solve the problem, Santa Monica Beach will help, but that's not where most of this is coming from. So that's where we have to go to the countries where most of this waste that is being produced is not being captured. And this has all kinds of other implications for public health and quality of life and things like that. Once you get past that stage, that is where the kinds of policies that Megan talked about so well, I think, become critical, because then really it is about behavior change, and whether the behavior change is a result of legislation or economic motivation or whatever it is, that's the part that has to happen. So I'm actually really glad that Megan finished the talk, because I think that's really hopeful, and I'm wondering, my question for her is, California is such a leader in this, as many environmental issues, and is there any kind of effort to put forth a handbook for, Iowa to say, like, how can we put these things in place? How can we get the grassroots going? What are the tools that we need? I think California's overcome a lot of the major hurdles through the, probably lawsuits from the industries and things like that. So those may not go away, or maybe they will, but, how can you put that into place in other states?
That's a really great question. So some state agencies in California, like the California Coastal Commission, and some local conservation groups, like Surfrider Foundation, have put together sort of best management practices, lists of policies that everyone can do, lists of stormwater controls that municipal governments can implement to address the problem. But it's true that California is a leader in this, but I don't think that California is often held out as this really special environmental creature that none of the other states can replicate, but I don't think that's true. And as I gave you a little background look at what it took to pass just the bag ban in California, it's hard. We have the plastics industry too. They're a powerful lobby, as they are everywhere in the United States. We have a lot of coastline, but we also have a lot of inland governments who are like, why should I care about this problem? So in this way, it's kind of a microcosm for a lot of other communities. And what's really been helpful is talking about the costs to local governments and talking about how effective local policies have been and how they have not caused significant economic disruption, or, when the first plastic bag bans were passed, people said, oh, everyone's going to get E. coli in San Francisco because they're going to be reusing these dirty bags, and it's unhygienic, and there's going to be massive consumer rioting, but there wasn't. Nothing happened.
One of the solutions you emphasized was increasing the recycling rate, and as I understood the presentations, the single most effective mechanism has been to mandate bottle returns, and 10 states have that, and others don't. But I was sort of curious what the underlying economics of recycling are. I go every Saturday and I bring my plastic milk jug and I put it in some big recycling bin. So it goes through some kind of recycling process. But what are the economics of plastic recycling? How can are there public policy solutions to make that part of the cycle more economically attractive? Because if one could create an industry that focused on recycling plastics, that would go a long way towards solving the problem.
That's a big question. I'm sure everyone has things to say about it as well, but recycling is managed differently in all of the localities where it's managed. It can be really expensive. There are different models. Even California's bottle bill, which is considered the most cost-effective in the nation, operates at $100 million a year structural deficit. So, there are challenges to overcome, and a lot of plastics, increasingly plastics, are not made of easily recyclable materials, which is another challenge. So, I could say a lot more, but I'll let you guys speak.
Well, I actually have a question on the data. You said that bottle bills have been shown to reduce litter, and so I'd be interested to know where those data are, because I have heard and others have said that bottle bills do a fantastic job of increasing recycling rates. If we look at the states that have bottle bills, they absolutely do that. But one of the questions that often comes up, and I think speaking with some waste management experts, they would say that whether you recycle or throw a bottle into the trash can, through the marine debris lens and what's getting to the ocean, it might not make much of a difference. It's not necessarily that pathway where the flow of trash is entering. It's happening outside those cans, outside that box. And so it's great to hear if there are data to prove it reduces litter, because I wasn't previously aware.
So the data that I have is from Hawaii. It reduced litter 14% to 7%, particularly plastic beverage container litter. I don't have California's.
I just want to comment on the economics of that. My understanding, not being an economist or in the plastics industry, is that it's actually not economically viable because the market for recycled plastic doesn't exist because it's so cheap to produce new plastic. So there's just a fundamental imbalance there that you can't have profitability sort of drive that.
So why don't we open it up for comment? Is anyone going to move on a recycling bottle bill, not a plastic bag recycling bill in Vermont? It seems like an idea. That'd be right.
Yeah, so I work for a solid waste management district in Vermont, and we own a materials recovery facility for recycling in Chittenden County. And so when we talk about a lot of this data, and particularly, Dr. Lavendar was talking about the frustration of seeing Photoshop pictures of these gyres and things, and it's all to make a good, worthy case, but I just encourage that we use statistics that mean something. So my question would be, did Hawaii have single stream recycling? What was their recycling rate? What infrastructure did they already have? That may or may not have contributed to the litter there. The bottle bill is quite contentious because of inefficiencies and costs inherent in it. And is it capturing the material, or is it just scavenging off of single stream recycling that's already there? So we've been down this road. plastic bags. We have an efficient system, or I don't know about efficient, but we have a system where in fact plastic bags that are collected by grocery stores are purchased by Trex, the plastic lumber company, and they're backhauled in empty produce trucks. So you're capturing an efficiency there. These aren't ideal systems. They can certainly be improved, but I would just encourage, as we have these discussions, talk to your solid waste management professionals and get the full story. Thank you very much.
Thank you. And I agree completely. We need all the agencies at the table as well as industry, everyone.
Back of the room. I guess I'm not in charge.
It's a maze to get back here.
I think John was looking the other way, but in any case, this qualifies as the back of the room. This is a fascinating discussion, and when I looked at the beach in Hawaii pictures, all I could think of is that that's not a problem, that's a solution. There you have a passive collector of plastic, and what is anybody learning about how to collect plastic by just being in the right place? And of course, I went online and found out that TED has a young man who gives a talk about a passive collector. So one question is anybody actively pursuing what appears to be a huge opportunity here, regardless of the economics presently not flowing that way in terms of recycling? But is there a large move for mining all of this material out of the ocean? And the sub-question, which is completely unrelated but underlies it all, is the E word, which is endocrine disruptors. And you have avoided it, I think, in order to not inflate or inflame the discussion. But will that not throw I mean, sometimes you have to light a bigger fire to get people to pay attention, and that's about the biggest fire that I'm aware of.
We have that was a two-part question.
That's a two-part question. Forget about the first part. The mining is insignificant. Talk about the disruptors, please.
Disruptors, okay. Okay, so this is I got rushed at the end. I didn't really mean to skim over it. That wasn't my intention. So the line of evidence, this is a line of evidence that's being actively pursued right now. What we do know is we know that plastics contain some additives, things like BPA, that have endocrine disrupting capabilities. We also know that the plastics floating out in the ocean can sorb things like DDT and PCBs and things that have been put out into the ocean previously. So we know that these things have higher concentrations than you would find in surrounding seawater. We also know that in the case of microplastics, that a wide variety of organisms are eating this stuff. But what we don't know is how much of these chemicals are actually transferring into the tissues of the organisms that eat the plastics. So this, as you can imagine, is complex. It depends on the type of organism, how long the plastic stays in the gut, the pH, the other kind of food that's in there, the type of plastic, the type of chemical. So it's really baseline science that has to happen in the laboratory. At this point, it has been, for some particular cases, we have seen a transfer of these contaminants into tissue. So that's where the concern lies. It can happen. But when you start to take it out of the laboratory and into the natural environment, the question is, how much plastic does say we're talking about tuna, how much plastic does a tuna encounter in its lifespan? How much does it ingest? How much passes right through it? How contaminated is that plastic? Even if it eats a lot of contaminated plastic and the contaminants transfer into the tissue, that fish is eating a lot of other natural prey that is also contaminated. So there's this huge chain of questions. In terms of raising the public awareness, it's absolutely necessary to say there's a reason to worry. I just am on the side of, accuracy is best, and you can do a lot of damage if you sort of raise the red flag prematurely or become very alarmist, because then people don't trust you, and then they think that you're just trying to get them all worked up because you're an activist. So it's a really delicate balance to be able to convey that information accurately, and to say there is concern, but also, I think, the Ebola situation is a great example of this, right? I mean, just listen to the way people are communicating about should you be concerned or not that somebody in New York now has Ebola. It's a very similar, different level, but a similar kind of question.
And can I just comment on the mining piece as well? So there are some companies out there that have tested and have generated products. Method is a great example, making soap dispensers that are made with ocean plastics. To date, there hasn't been a company that has created an entire line that is scalable only using plastics, because there are real costs associated with it. And most of the products that are made are more of a marketing scheme than they are a long-term kind of viable source of material. I think the larger point or question you raised is the concept of an ocean cleanup, and I think Boyan Slot is the gentleman you're talking about, a young 20-year-old designer in Europe, and he and I have had the opportunity to chat sometimes, and I think our position, and I don't want to speak for everyone, my position, Ocean Conservancy's position, is that the awareness and the ingenuity and creativity he has brought to the issue is phenomenal, and hopefully a decade from now, 15 years from now, we can put in place these ocean technologies to clean up. But technological, oceanographic reasons aside, putting something out there now to clean up the ocean would be like letting the oil spill out of the Gulf of Mexico, the Deepwater Horizon, while we just clean off the surface. We need to stop it at its source. And so thinking about a technology like the Baltimore water wheel, if you haven't heard of it, I highly recommend you Google it. It's this great passive device, sits right at the mouth of one of the rivers that goes into Baltimore Harbor, and it just operates like a ferry wheel, collects trash, dumps it into a dumpster that throughout the day is then removed and dumped. And it's been a really great success, not just in removing trash, but they put on a great educational exhibit there. People come to see it. It's a great lesson and it raises the awareness. So certainly not against cleanup in the marine environment, but we need to be strategic about where we place those cleanup efforts to maximize efficiency and resources.
What raised in my mind, you focus on working with corporations to figure out a financing mechanism to establish centralized trash collection facilities. I wonder how that strategy compares with a strategy that focuses on the packaging practices of individual companies. And so what we want you to do is we don't want you to finance a big, expensive method of cleaning up your trash. We want you to reduce the source, and so we want you to change your packaging practices. Coca-Cola could make a big difference. Is that part of the mix? How does that fit into your strategy?
I think there's a suite of solutions, and certainly product and material redesign is under that umbrella of solutions. I think one of the challenges you run into is if we only come at this from an ocean lens and think about material substitutions you can make to address ocean plastics, and you substitute glass or you substitute other materials, there's a whole host of other reasons from a life cycle perspective that we might solve the ocean problem in some ways, but we exacerbate, carbon emissions, we exacerbate all the other things. And so in a lot of places, plastics are the optimal material to be used, and plastics in our daily lives are not a problem. The problem is that these materials are escaping our hands, are escaping waste management infrastructure if it exists, and when they enter the marine environment, we see the very real threat and impacts that they pose. So I think there is absolutely a spectrum of interventions, material redesign being one of them.
Yes, thank you. I just had a quick comment and then a question for Megan. Shortly after leaving the law school here in, I think it was 99, I went to work with a market research group, and when I left the market research group, I worked independently for a summer on a research project, which goes to your point about Iowa, which was trying to find a solution for recycled ag plastic through the Franklin County Industrial Development. And so I did the market research on the project this guy was looking at, and a large Canadian company had funded 2 of their engineers to go up to PEI, up in the maritime provinces, and basically said, get us a solution for cleaning ag plastic. Ag plastic, if you were going to look at an inland source of plastic, is a big problem because of the worries with farmers that get rid of it by a lot of the time just burning it. Low temperature out in the back of the farm, where does the plastic get deposited? On their cornfields, goes right back into the system. And so this was an area of interest. I will say that the results of my study were it wasn't economically feasible for reasons, some of which were just by the person who was trying to do this. But the main linkage breakdown was we had, you mentioned Trex. Anybody, if you're familiar with Trex, it's a composite wood. It doesn't have much structural integrity, but you can use it for decking and flat surfaces. And that's what we had, actually, a DOT contract to replace all the, they're called breakaway blocks on the guardrails that are made out of, pressure treated. They have to be replaced, and pressure treated prices were going up, so we would replace them with these composite breakaway blocks in the guardrails made out of recycled ag film, which is, by the way, it's all that black and white. Mostly you see all the white bales that are wrapped in it, or bunkers are covered with it. So my point, though, is that the distribution was by far the biggest breakdown in the linkage. Farmers weren't going to do anything with it unless you paid them. How are you going to pay to pick it up? How are you going to get it to the facility? But the industry had invested money in trying to find a way to clean this. I mean, there's huge amounts of this stuff created, and it's just low-grade plastic film. And so anyway, my point is that distribution seemed, at least in that context, to be one of the biggest problems. Collection. And the second point to Megan was, I was really surprised to hear that there was so much kickback from the Grocers Association. And if it was me, I'd be asking them why would there be that negative kickback to reducing the amount of plastic bags at the grocery store? I mean, the damn things are so flimsy now, they put 2 to get your groceries out the door anyway. You know, and you see people, they're ripping off. I mean, if that's a plot, it's working. You know, you see people, groceries spilling out on the road, you know, when you walk out the parking lot. I mean, I don't know what, I mean, I don't know. I guess I'm really baffled by that. And if there's like a National Association of Grocers, somebody should be knocking on their door and saying, what's the problem?
I'm with you. It seems common sense. A lot of the concerns have been concerns that recycled content paper bags cost more than these thin film plastic bags. These things are really, really cheap. And also worries about how consumers were going to react. So one of the ways that we overcame this in California was allowing the grocers to keep that 10-cent fee that they collected. So now they're required to charge 10 cents for paper bags. And grocers now keep that fee, and that fee goes towards buying paper bags and towards other implementation costs and educating consumers. And so that was one way to get the Grocers Association on board. But it was also helpful to just show, look at all these cities, look at San Francisco, Los Angeles, some of the biggest cities in the country ban plastic bags. And it hasn't really, people are still going to Walmart and buying their groceries. It hasn't really impacted anyone in a meaningful way.
I have a question for Dr. Law about the map you showed about the distribution of floating plastic in the ocean. Your metric for it was, if I recall, the number of pieces per area. Was there any measure done based on volume or weight? And if so, did the distribution vary? And is there any difference in the detrimental effects based on different measurements?
Yeah, that's a great question. In general, let me just say that this science is very new. And people have documented plastic in the ocean since the 70s, but the science is still in its infancy. So these are the kinds of questions we're asking. The map I showed you was data collected by SCA. That's the largest and longest time series of plastic data in the ocean. Because we have students picking it out on the boat, we don't have any, at least currently we don't have any method to bring it back and weigh it. We don't have those data. Other people who go out do try to replicate the mass. And we do know the types of plastic that are floating out there, so we can sort of make some gross estimates. But in terms of asking the detailed questions about does it matter what the mass or volume is or what the type of material is, that's a little bit farther than we can go right now. So we're working on it.
Okay, thank you.
I just think the question that you asked, John, about the economics is so important because we all know that that's sometimes the biggest driver of all. I wanted to offer in the electronics arena that I work in, there's been a really powerful solution, an economic driver, and that is voluntary standards. The manufacturers of new electronics were only one of many stakeholders at the table to create voluntary standards for designing new electronic products, and one of the requirements that was inserted, not by the manufacturers of course, but by purchasers, so we're talking government agencies and corporate purchasers, was a requirement for post-consumer content for plastics. And the manufacturers fought it, but they lost that battle because the purchasers were so committed to it. And in the first year of the standard's life, quite a few, maybe 4 or 5 years ago, because both Presidents Bush and Obama required the federal agencies to purchase these new electronics that had this post-consumer content. We now are seeing, we had $60 billion worth of sales in new electronics, and we're now seeing this whole industry grow up around recovering the plastics from electronics because the manufacturers need it in order to get their products registered to this voluntary standard. So I think it's just a good reminder that sometimes these voluntary standard programs can really drive, the regulatory movement later on, hopefully. I just want to share a sign of hope.
Thanks.
A couple more questions?
I think we have time for one.
Hi, I'm Mac Jones. I was wondering, what is the cosmetic industry's response to the whole microbead issue, either from the ban or is there any alternatives that they are focusing on?
So I can speak to that. So Procter & Gamble and Johnson & Johnson have voluntarily agreed to remove microbeads from all of their products. So they'll continue to sell what products they currently have, but they won't use microbeads in any future products. That's voluntary. And there are alternatives. Basically, the microbeads are used as exfoliants, and so we can use natural things like crushed up walnut shells or sand or sea salt, things that are more natural alternatives instead of these plastic microbeads. There is some concern with the voluntary use of alternatives about what alternatives these industries are going to select, and so there could still be a really important role for regulation and confirming that the alternatives that we move to, as Nick was talking about, when we move to alternatives, we want to make sure that we are not being maladaptive, that we're picking the right alternatives.
You done? Join me in thanking our excellent panel.